Okay, now let's start with example 2. Let us see how we are going to differentiate a function like this. Before we do that, I want to ask you a question. Do you happen to know what is the derivative of x to the power 50? I hope you remember from the power rule that this is given by 50 times x to the power 49. So what if we have something else in place of this x? Well, in that case, the derivative will be given by 50 times this box to the power 49. But we have to make sure that we multiply it with the derivative of this box. Why? Because this box is your inner layer, and your chain rule says that you have to create a chain of derivatives. Okay, and you have to include the derivative of your inner layer in that chain. All right, so please remember this. Okay, let's apply this to the given problem. We want to find the derivative of this function. This function is something to the power 50, this box to the power 50. Therefore, the derivative will be 50 times the box to the power of 49 times the derivative of this box, which is same as derivative of 4x squared is 8x, derivative of 3x is 3. And that is your answer. Now let's start with example 3. We have to find the derivative of this function. Okay. Don't start just yet. Let's move this to the numerator. Can you tell me what will happen to the exponent if I move this to the numerator? Absolutely. It will change sign. So 45 in the denominator, 45 power in the denominator will become negative 45 power in the numerator. Now you have to differentiate this function. How does this function look like? It looks like something to the power of negative 45. It looks like a box to the power of negative 45, which means that its derivative will be given by negative 45 times 4x squared minus 3x to the what power? To the power negative 45 minus 1. Am I forgetting something? Yes, you have to also multiply it with the derivative of the box, the derivative of the inner layer. Derivative of 4x squared is 8x, derivative of 3x is 3, and that is your answer. Now let's find the derivative of this function. Let me rewrite the function. If I want to move this denominator to the numerator, what will happen to the exponent? Yes, it will change sign. So we will now have a negative 1/2 in the power. Okay. All right. So we are going to use the chain rule to find the derivative of this function. This function looks like this box to the power of negative 1/2. Times the derivative of this inner layer. As a result, this is what we have. The derivative of 4x squared is 8x, and the derivative of 3x is just 3. Let's do one more of this kind. Look at your function. What is this? This means power 1 over 5. Let's see the radicand that we have here. It is x squared plus 3 times. What power of x here? 1/2. So this is your function that you need to differentiate. Okay, your function looks like a box to the power of 1 over 5. Derivative of x squared is 2x. Derivative of 3x to the 1/2 is 3 times 1/2 x to the 1/2 minus 1, and the derivative of 5 is 0. And that is your answer. One last problem of this kind. Let's rewrite the function in a better form, which is easy to differentiate. As you can see, this is your inner layer. I'm going to enclose it in a box. So the function that you have right now looks like this. Okay, so its derivative using the chain rule will look like this. Let's find it real quick. Derivative of x squared is 2x. Derivative of x to the negative 3 is negative 3. X to the power negative